So hi guys, I'm here to explain about the duality property of continuous time Fourier transform. Duality property is one of the properties of Fourier transform. So if any time domain signal x of t is given, then we can find the Fourier transform of that in the frequency domain as x of omega or x of j omega. So by that equation, the Fourier transform of time domain signal x of t can be given as x of omega equal to integration of limits minus infinity to infinity into x of t into e power minus j omega t dt, which is a standard equation. So we have a look at the duality property of continuous time Fourier transform. So if a time domain signal x of t is given, then we have the Fourier transform in frequency domain as capital X of omega. Now by replacing omega with t, we form a new time domain function capital X of t. So the that capital X of t will have a Fourier transform of 2 pi into x of minus omega, which is in frequency domain, but we are representing with it as original time function. So mathematically, duality property of continuous time Fourier transform states that small x of t, if we apply the Fourier transform to the time domain signal, we get the Fourier transform of time domain signal as capital X of omega. Then according to duality property, capital X of t, by applying Fourier transform, we get that as 2 pi into x of minus omega. So for Fourier transform of capital X of t is given as 2 pi into x of minus omega. So we look at the proof for further understanding of duality property. From the definition of inverse Fourier transform, we have small x of t equal to 1 by 2 pi into integration limits minus infinity to infinity capital X of omega into e power j omega t d omega. So we now transfer the 2 pi from right hand side to left hand side, or simply multiply the equation with 2 pi on both sides. We get the result as 2 pi into x of t equal to integration limits minus infinity to infinity capital X of omega e power j omega t dt. Now we replace t with minus t. So we get the resulted equation as 2 pi into x of minus t equal to integration minus infinity to infinity capital X of omega into e power minus j omega t d omega. Now on interchanging t and omega, we get the resulted equation as 2 pi into x of minus omega equal to minus infinity to infinity x of t into e power minus j omega t dt. Now the right side equation is nothing but the Fourier transform of the given time domain signal capital X of t. So we write that as Fourier transform of x of t. So we finally we get the result as Fourier transform of capital X of t equal to 2 pi into x of minus omega, which is nothing but the duality property. It can also be written as x of t on Fourier transform we get as 2 pi into x of minus omega. So we have a time domain signal capital X of t, then by applying Fourier transform we get that as 2 pi into x of minus omega in frequency domain. So if the function we have taken is an even function, then by the definition of even function we write that function as x of minus omega equal to x of omega, means the value of f of x is equal to f of minus x, which is the definition of even function. Therefore, duality property of Fourier transform for even functions can be written as capital X of t on Fourier transform we get 2 pi into x of omega. So we have a time domain signal x of t on Fourier transform we get 2 pi into x of omega as the Fourier transform in frequency domain. So for further understanding we will look at an example. So we have a time domain signal x of t that equal to 1 by a square plus t square. Now it is, if we apply the Fourier transform we get as uh, f of e power minus a mod t that equal to 2a by a square plus omega square, which is the double-sided exponential function. Means x of e power minus a into mod t equal to e power a mod t when t is less than 0, that equal to e power minus a into t, that is when t is greater than 0. So the Fourier transform of double-sided exponential function is defined as f of e power minus a into mod t, that equal to a by a square plus omega square. We have the time domain signal as x of t, that equal to 1 by a square plus t square. So we multiply by 2a, we get now that function as f of 2a by a square plus t square, that equal to 2 pi into e power minus a into minus omega. Now by the duality property, we apply the Fourier transform of time domain signal x of t, and we get the Fourier transform of 2 pi into x of minus omega. So we are replacing t with minus omega. So we get as f of 2a by a square plus t square, that equal to 2 pi into e power minus a into mod of minus omega. Here t is replaced by minus omega. So originally we replaced t with minus t, and then t is replaced with omega. So we get the equation as 2 pi into e power minus a into mod of minus omega. So we send that to a to right hand side. Then we get the equation as f of 1 by a square plus t square, that equal to 1 by 2a into 2 pi into e power minus a into mod of omega. So by the definition of mod function, mod of minus x is equal to x. Mod function is used to make an equation positive. That's the purpose of using mod function. Therefore, the Fourier transform can be written as f of capital X of t, f of x of t, that is equal to f of 1 by a square plus t square, that equal to pi into e power minus a into mod omega by a.